G'day, in this video we're going to be looking at solving inequations. And if you haven't seen these before, then you're probably thinking, what the heck is an inequation? And I'll tell you. So, number line. So in our number line we have 0, 1, 2, 3, etc. You probably know, the numbers. Remember them numbers? Let's have a look at this. If we have, let's have a look. If we write x is greater than 1, what does that mean in terms of our number line? Well, that means that x could be equal to 6, x could be equal to 21.3, x could be equal to 1.001, that sort of thing. As long as it's bigger than 1, they're the sort of the possible values for x. The way we draw that on the number line is it's greater than 1 but not equal to 1. So it's not equal to 1. So what we do is a little circle to show that it doesn't equal 1. And then we just do this arrow like that to show these are the possible values of x. Anything bigger than 1 and forwards, anything greater than that is that. So that's where we write x greater than 1, like that. What about if it was x greater or equal to 1? How would that look like? Well, in that case, if it can be equal to 1, then we'd colour this little dot in to show that it could also be on 1 as well. It could also be x equal to 1 is another possible answer here. Okay, so that's what we mean with inequations. X is greater or equal to 1. That's what it means. Okay, let's just have a look at a sort of a slightly different situation. Let's have a look at a less than. What does that mean? Okay, so greater than basically just goes to the right. So if you have x less than less than 3, it's not really interesting. 2. Okay, let's go 2.5. Okay, x is less than 2.5. Think about the sort of answers that x could have. It's just telling you that it's less than 2.5. Okay, so it's so what could it be? X could be equal to 0. That's less than 2.5. X could be equal to negative 3. That's less than 2.5. X could be equal to 2.103. That's less than 2.5. In fact, if 2.5 on this number line is this point here, and I'm going to draw it with an open dot because it doesn't equal 2.5, it's less than 2.5, then the numbers that are less than 2.5 are in this direction. So we just draw a little arrow to show that it's all those numbers back there. And the arrows show that it goes forever. Because if you think about it, x could be negative 1,296,458 billion or whatever, It doesn't matter. Whatever, it goes forever back in that direction. Okay, it goes to negative infinity. So that's what we're doing. If it was equal to 2.5, then we would colour the little dot in to show that it could also equal that point there. And that's what we're talking about with inequations. Let's now look at solving inequations. And the rule of thumb is, well, firstly, you solve them exactly like equations. Exactly. So you just move things, divide things, add things. Everything you do with an equation you do, but with one exception. Except, and let me write this, except when dividing or multiplying by a negative number. Okay, so if you've got the equation and you divide or multiply by a negative number, you have to watch out. This is the important thing. When dividing or multiplying by a negative number, you need to flip the inequality sign. And I can't stress that enough. Flip the inequality sign. Only when you're dividing or multiplying by a negative number. No better way. Examples. Here we go. So I'm just going to solve a bunch of equations. So let's do 2x plus 1 is greater than 19. Let's have a look at this. So, like I said, you solve it exactly like you would an equation. What would you do if this was 2x plus 1 equals 19? What would you do? You'd move the 1 over to this side. So let's do it. Let's move the 1 over to this side. what do you get? You get 2x, leave it as greater than, don't change it. 19 minus 1, so that's 18. Okay, so when that moves to the other side. What would you do if you had 2x equals 18? Well, you'd divide by 2, wouldn't you, to get it to the other side. So therefore, let's divide both sides by 2. X is greater than 18 divided by 2, 9. And that is your answer. Hang on, did I check the golden rule? Did I divide or multiply by any negative numbers? No, I didn't. I divided by 2, but that's not a negative number, so I'm okay. So that is all fine. The answer is x is greater than 9. In other words, if you had this inequality here, then any number that's bigger than 9 will satisfy this equation. Let's just pick one. Let's say x is equal to 20. If x is equal to 20, 2 times 20, 40 plus 1, 41 is greater than 19. That's true. But if I chose something that's not greater than that, let me choose 8. What about if x is equal to 8? 2 times 8 is 16. 16 plus 1, we get 17. Is 17 greater than 19? No, that does not work. So because x has to be greater than 9, this is bad. Okay, so that's what we're doing here. Let's do another example. Okay, let's go 9 minus 3x is less than 1 minus 3 is less than 5. Okay, let's do this. Here we go. Right. Again, just think of it purely as what would you do as an equation. 9 minus 3x equals 5. What would you do? Well, if it was me, I would move this 9 to that side firstly. Okay, so that's fine. Are we dividing or subtracting? Multiplying by a negative number? No. So positive 9 moves to that side, becomes negative 9. So therefore, negative 3x, leave the sign as it is, do not change it. 5 minus 9, 5 minus 9 is negative 4. Good. What do we do next? What would you do if you had negative 3x equals negative 4? Well, you want to get rid of this negative 3, so I want to divide by negative 3. Hang on, dividing by negative 3. Okay, so we've got x, we're going to divide by negative 3, so we're going to have negative 4 divided by negative 3, but we're dividing by negative 3. So what we do is instead of having less than, the sign flips. This is the important part. It flips here, okay? So you've got to be really, really careful. When you divide or multiply by a negative number, it flips over, okay? So simplify that out. X is greater than 4/3. Negative 4 divided by 3. That's the answer here, okay? So you just got to make sure you follow those rules. That's all there is to inequalities. Okay, I'll just do probably one more example. That's all there is to it. Okay, let's do 3x over, let's just make it interesting, negative 3x over negative 7. Yeah, we'll leave it like that. Is greater or equal to 1. Let's just do that. It's not very interesting. Anyway, we'll leave it like that. Okay, let's solve this. Let's go. Yeah, maybe so. I might just say plus x. Let's just do something a little bit more interesting. Okay. Here we go. What do we have to do? Well, just think about what you would do if this was an equals 1 plus x. What would you do if you were trying to solve this? What I would do is get rid of this negative 7 down the bottom line. I would move that first. Okay, and so let's do that. How do we get rid of a negative 7 here? We're going to multiply both sides by negative 7. Okay, so let's multiply both sides by negative 7. Okay, so we've got 1 plus x. We're going to have negative 7 times 1 plus x. Now, we've multiplied by a negative number, so that greater than sign there becomes a less than sign, and you keep the equals. If there's an equals on it, you keep it there. Okay, so it just flips around, changes direction. And there we've got negative 3x is less than or equal to, we'll just expand this out, negative 7 minus 7x. what do we do from here? Just like you would do if this was an equation, I want to move these x, this negative 7x, over to this side. So therefore, and am I multiplying or dividing by a negative number? No, I'm adding here. So adding and subtracting is fine. So negative 3x plus 7x, we get 4x. Still less than or equal to, I haven't done anything to change that, is negative 7. Therefore, x is less than or equal to, I want to divide by 4, that is fine, we don't need to swap there because it's a positive number. Divide by 4, negative 7 over 4, and that's your answer there. X is less than or equal to negative 7 over 4, and that's how to solve inequalities. Go away, have some fun, enjoy them. See ya.